Go live, go live. No, I'm not. I can't be alive. I am live. I am alive. I'm alive. I'm alive. Ah, you. Let's roll ahead again. Let us try low physics. And this is gonna be a bit shorter, maybe 1 or 2 hours max, but gonna be fine. Also, I can't believe it. Jingle Bells got its first view. I'm so proud. Okay, anyways, back to work. Here's question. Here's question. A 1.2 kilogram ball. Ball of 1. Maybe I'll write the mass here. Mass equals 1.2. Okay, let me move some stuff. You go there, you go there. Wow. That's a K.5 kilograms. And then we have a. It's question weirdly, it says speed, but I think it means velocity. I'm gonna say velocity of negative 25 meters per second. It hits the ground. I'm gonna call it no initial. I'm not gonna do 0. Or is it going up? Rebounds. I'm gonna name it F for 4. So it'll look weird, almost like final. But don't worry, it's gonna be fine. And this is R for rebound. So this is up, so 10 meters per second. Magnitude, average force, ball. So it goes down at 25. Negative 25 meters per second. And then it jumps, well, up 10 meters per second. And then we gotta figure out the force. This is, I know it uses the linear moment, the momentum thingy. So the force. Now what should I call it? I'm gonna say force P for momentum. Technically uses lowercase p. So this is a change in momentum over change in time, and it's momentum was mass 2 velocity 2 minus mass 1 velocity 1 all over t2 minus t1. Is it? I guess. Yeah. Well, it could have been initial time. Doesn't matter. That works. And in this case, it's 1.2. Oh god. Actually, maybe I can do mass times modify the bit and have velocity 2 minus velocity 1, the vector quantities, and then well, this is going to be t2 because we are starting at 0. And now plugging in some values we get. What do we get? Oh, it's yeah, 1.2. Wait, no. It's 10 minus 25. 25. Yeah. All over 20 milliseconds is. Wait, how do the units convert? I know it's 0.02 milliseconds, but seconds, but Wait a second, quick second. 1000, holy crap. Where's it? Okay, millicenti deci is second. So 10, 100,000. So it's second, decisecond, centisecond, and millisecond? Yeah, I got 1000. So I'm gonna do it more officially. So 20 ms over 1 times 1000 ms over 1s. So that's 2 over 100 s, which is 0.02 s. Okay, 0.02 s. Look at that, the metric system so overpowered with its convenience. I can't imagine using another system. Okay, let me calculate. 1.2 times 10, technically negative cancel out, it's 10 plus 25 divided by 0.02. And it is 2100 newtons of force. This is the you just wanted the magnitude as well. Very importantly, you only wanted the magnitude. I didn't want the. I did not want the, direction. But that's not important. Okay, that's U1 down. And now we can go to number 2. I hope I left enough room for drawings. Okay. So there's some dude laying. Sure. I'm gonna ball. Well, I didn't have to. It's just stone. I'm gonna say it's a stone ball. Push it. Push it. Dude pushes it. Negligible friction, cool. Okay, so 68. So let me say mass s, sub s. So mass stone is 68 grams, which is equal to. Okay, so it's kilo. So there's. Isn't it gram? Gigagram, hectogram, and then kilogram, right? So it's 68 over 1 times. Okay, gram, gigagram, hectogram, and then kilogram. Let me just check that. Where's one? I never have my table. Yeah, there's a deca, then there's a hecto, and there's a kilo. So it's 1, 2, 3. 1, 2, 3. Which is all. Yeah, one. Nah, I mean, I can skip it to here. So the grams would have been cancelled. I would be left with kilograms. And 1, 2, 3. 0.068 kilograms, right? Let me make sure. Oh, 60 G in kg. Yes, I'm correct. It feels good to be correct. Where's the song? I don't need that anymore. My vegetables here. I'll re-put them here. Mass of stone is 0.068 kilograms, can't forget that. Mass of man, where is it? Yeah, man. Mass of man is 91 kilograms, 91 kilograms. And the speed, well, it does say speed is 4 meters per second. Wow. Wow. Okay, there we go. That's amazing work, me. Because she pushes it, it pushes it on him as well. You know, equivalencies and shit. What speed does the dude achieve? Yes. Okay. I mean, we already know the force. Force momentum is changing momentum. Changing momentum over changing time, which is mass 2, velocity 2. I mean, if we're working with velocities, then I mean, we can, for this, fuck. I mean, it's supposed to be velocity, so. But with speed, so we're still in a positive direction pushing it. You know? So we can just ignore it. Ignore the vector sign. Even though it's positioned. Mass 1, velocity 2, over. Maybe let's put it there anyways. Even though the wording is really weird, I'm just gonna leave it to T. It didn't say anything about the time. About the time. Curious. So I don't think that's gonna help me actually. Because I have time. Maybe I think about the formulae. I see. So there's an the initial momentum. Okay, so there's another formula of the initial one. The first object, initial momentum of the second object is supposed to be equal to the final momentum of the first object plus the final momentum of the second object. If I wish to put the values in, it's mass 1, velocity 1, plus mass 1 plus no mass 1 times velocity 2. Wait, mass 2, mass 2, mass 1, mass 1 velocity. Well, I should have the one initial. That's a bit weird, but I final plus mass 2 velocity. Wait, what? I final, one final, the first final. This is second final. So plug it in some numbers we can get. Maybe I should be a bit zoomed in. We get 91 times isn't it 0? Because we're not moving yet. Are we supposed to assume that we are moving? Okay, I'm gonna try assuming first that that the left side is completely zeroed out. Because technically, at the very moment, we are not moving, but maybe it means it's talking about in a different manner. So let me think about this. It would be negative measure 1, negative 91 times some velocity final. 1 final is equal to 0.068. Wait, wasn't it 0.000? 0.068 is good times is 4.0 meters per second, and I mean, we're gonna presume that final velocity is going to be negative anyways. Or we could take the magnitude anyways. It does ask what speed, so it does ask for the magnitude, the scalar quantity only. Let me try to see if this is the way to do it. Maybe it is, maybe it ain't. Apparently it is. So yeah, this was all 0. Perfect. 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 Is it because we could... Is it because we could... Yeah, I guess we can assume for both of them for 0. Anyways, this is all... so, final velocity... Initial... No, I could have said man velocity. Instead of 1 velocity. Anyways, it's... Wait, what? Velocity? Wait a minute. Oh yeah, it is correct. Well, we're saying speed, so we can ignore that. It's for consistency. Physics is weird about this. Anyway, 0.00... Wait, no, it's... 0 is 0. That isn't actually 0, there, ain't it? 298, which is roughly 0.003 meters per second. So fast our dude is moving. Now, we wanted to have the technically velocity, like the quantity, you'd say it's negative because it's going to the east. But we don't need that. Unless you're defining things differently. But it could be a positive. Anyways, number 3. Amazing progress. I can't believe it. I'm actually doing pretty decently. A railroad car? You mean a train? Yeah, something. Or tram? Is it trammy? Train? No, there's another type. I can't remember its name. Is it tram? God damn it, now I'm curious. I'm getting sidetracked, but that's not important. Tram? Is it tram? No. Oh, it's a streetcar, yeah. Trolley was the name. But I said tram, which is also correct. So it makes it correct. Okay, okay, so it's this, whatever this thing is. I'm gonna give it wheels. Moved at a constant speed, okay, somewhere 3.2 meters per second. I'm gonna put the speed as 3.2 meters per second. That's constant, by the way. You telling me constant? That's very fascinating. I'm gonna green elevator. There's a grain cubicle system, I guess. It's shitting stuff out. At a how do I say my rate? I'm gonna make rate R. That's probably wrong, not loud, but I shall. If I have 40 kilograms per minute, this is a quite amount of difficult ones. Magnitude of the force to keep the car moving at constant speed if the friction is negligible. It has to keep moving at some force. Oh, every minute there's 540 kilograms of weight. Wait. Huh. This is a linear momentum question. Oh no, I need different physics. What? Elastic, elastic. Well. Hello, 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 hello. Is it nice? Rotation is oh boy. Nish. No. Well, momentum is mass times velocity. Right. Oh yeah. Force. Force. Oh yeah, vector force is change in P. Change in momentum over change in time. Well, how about we make 540 kilograms on times 1 over a minute times 60 as over 1. No, it's actually the other way around. X over 1 min. The cancel 540 divided by 60 kilograms per second. That's about, is it about 3, no 4, 5, I don't know. Not, isn't it 10, so 9, right? 9 kilograms per second. Make sure. It's about 9, let me space. 9 kilograms per second. So there's 2 velocity 2 minus velocity m1 velocity 2 velocity. Wait, yeah, right. 50 and T. So what the hell is the force at, okay, 9 times, what did you say? 3.20. I mean, the first one would be, is it 0? Let's just presume it's 0. If we are not taking into account the cars and weight. Or the trains. The trams, the trolleys. I mean, it is second, right? Is it? Cute news. Good numbers, no? I believe it. I cannot believe it. 28.8 newtons. Yes, I'm correct. We need 28.8 newtons of force constantly. So yeah, this was 0. 0. Because the mass is 0. Because we're ignoring the weight of the car machine. Great stuff. We're gonna have a constant force? A constant force of 29 newtons? Constantly? Or something like that to keep moving? I'll have to check what it specifically means. Actually, I'll make that a bit more down. I'm doing surprisingly well. That's not usually the case here. We have about an hour left. This time there's only 10 questions, huh? Okay, pellet gun fires 10 pellets. I don't know, I'm gonna make a gun. Mm. 10 pellets, 0.2 grams per second. 10 pellets of 2.2 grams per second with a speed of 2 divided by the wall. Okay, the wall. Wall. There's a wall. A wall. I'm gonna build a wall away. All those AI memes are really good. I guess we could do that. Whoop. Uh-huh. Yes. Yes, thank you. There's a wall. 1, 2, 3, 4, 5, 6. You know, 10 times, so it's, let's just take the mass is 0.002 kilograms, right? Because it's 2 times, what is 1,000 gram, decagram, kilogram, no, hectogram, and then kilogram. That one, and the 0 is moved 3 points, so 1, 2, 3. So 1, 0.2, 0.02, and 0.002. Yes. Yes. It's 10 per second. Again, I'm gonna put the rate. So the speed it's 500 milliseconds. What is the magnitude of the linear momentum of each pellet? Meter. Magnitude of linear momentum. I mean, momentum is just means velocity. Isn't it 0.002 times 500? Would it be? No, I don't think so, right? Would it? No. No, it can't be. I don't think so. Okay, never mind. It really is that simple. 500 meters per second, so it's about 1 kilogram meters per second. That's the rate. Because the 10 pellets can be ignored. We don't need that many pellets. We were only looking at each pellet. Okay, cool. That was surprisingly easy. I remember doing this sometime in the past. It was super hard and I didn't understand any of it. But now I understand for some reason. How magical is that? Really fascinating. Oh shit, look at that. I came back for round 2. Where's the kinetic energy of each pellet? Kinetic energy. So in equals 1/2 mass velocity squared of each pellet. Isn't it just 1/2 times 0.002 times 500 squared, which is divided by 2. 250, because it's 250, wait, that's kilograms, that's meters per second, but then the square, so it's meters squared per second squared, kilogram meters squared per second squared, and this is joules. Is that how joules work? Joule units. Okay, so it's it just is Newton meter. Newton's meter. So yeah, it's just joules. So 50 joules. J. Okay, cool. Again, simple. Oh my god. Can you believe it? Can you guess what it is? It's 6. And coming back for revenge again for the 6th time. What is the magnitude of the average force on the wall from the stream of pellets? This is fascinating. It's a stream. So what is the force? I'm gonna say average. Average? I'm gonna say wall. There's a wall. The force on the wall. It was changing momentum over changing time. Well, it's per second. Per second, so it's just 1 here. We can ignore it. We can just ignore that. So it's mass 2 velocity 2 minus mass 1 velocity 1, which is equal to mass, in our case because the mass is constant, velocity 2 minus velocity 1, velocity 1. Actually, I think there's a secret here. So I think something is gonna happen about that. So, which is that this is 0. Because if we are talking about, no, wait, no. This is 0, because if we presume the velocity 2 is the final velocity. So we presume that's the final velocity, and this would be the initial. Come on, the initial. Then the final would just be 0 because it's stopped. It's stopped by the rigid wall. Therefore, it's just the 0.002 times 500, which is 1 kilogram meters per second. However, and that's just for the 1. Now technically be negative, which is shit, but what would it be negative? I mean, if I follow the numbers, I'm gonna go with that. But since this is asking only for the magnitude, which is just so no direction, so we can ignore the negative. But this is also asking for all stream of bullets, so it's times 10. You know, each 10, that's per pellet, but we have 10 pellets. So therefore, it is 10 newtons, well, kgm as newtons, so 10 newtons of force. I am doing great. I know, finally, 7. What? The 7th. Can you guess? Can you already guess at the point? It comes for another round of revenge. Oh my god, I can't believe it. Okay, the pillars. Okay, this time we have the variable time is 0.555 milliseconds. So there's milli, deci, and then second. So that's 0.55 milliseconds times ms is as decaseconds, and then deciseconds, and then wait, how are you supposed to denote deca and deci? Conversion. Conversion. Level. Oh god, so long, so long. You've got a micro? Huh? Where do you come from? This is centi milli. It's very. Some of these are so very lacking. 2 steps. Oh, it doesn't matter. It's a 0.3. It's a point. The 3-pointer. 1, 2, 3. No one else. Oh, I mean milliseconds. Anyways, let's cancel, and we get Just put 3x 0.1. Is it like? Wait, is it 0.1? It's so. There's 55. 1, 2, 3. Right, seconds. Let me check that. 0.55 ms to is 3. I was correct. Woo. Can you believe it? You should, because I did. Yes, fascinating if you would move. Okay, what was the question even? Oh, what's now the magnificent force? Isn't it just on the wall? Isn't it just when they're going to take the magnitude? Is the 1 Wait, is it each? I guess it might be 10 divided by 0.0055, which is 1, 2, 3, 5, 5. No. Wait. Oh, no, wait. Wait. What did it say? Wait, what did it say? Oh, it's doing on the decision 10. That was 18 point. What was it? Was it 18? A lot of 18 newtons. Yeah. Which is just, I can say 18 newtons. 1018, 1818 newtons of force from each. Cause and force. Plus play time. There's a time. It's all to do with the timing. The forces. How many force? So much force. Oh. Oh. Alright, next one. It's number 8. Oh my god, can you believe it? What it is? What it is? It's actually a new question. My god. Who could have guessed? Okay, well, it's kind of similar though. There's a lot of bullets here. A lot of projectiles. Okay. So there's this bullet. There's this bullet. We know that bullet is. Yeah, that's a bullet. Okay, you're looking like this. No, you're looking like this now. Yeah, that's your bullet, Lucas. This is coming. I think pendulums. Oh fuck. Oh fuck it. You're looking like this now. And right is vertical. So the bullet stays inside. So it attacks this, and then we get boop, 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 boop. The bullet is inside, and the difference is about 12 cm centimeter decimeter meter. So 12 cm over 1 times 1 wait centimeter decimeters meter 1 meter 12 over 100, it's 1 2, so 0.12 meters. Well, that's good to make sure. 0.12 meters. You can remove that. Yes, for the extra space. That's a change in distance. Oh yeah, each of them have a nice mass of. The mass of the bullets. Oh, the mass of the bullet is 0. Wait, no, it's 10 grams. Then G, which is about 0.01 kilograms. Let's make sure 10 grams over 1 times gram, decagram, hectogram, and kilogram. So it's gram, decagram, hectogram, and kilogram. Kilograms and grams that cancel. One of the zeros cancel, and then this 1, 2. Is it 3? 0 would be 0.01. Wait, 0.001 or 0.01? Crap, now I'm lost. Think G in Kubi. It's 0.1, so it's 1 0, second 0, and then we quit. So here is a 0 and 0. This is the first point. So we move 0, and then we move another 0, and then we put the 0 there. Okay, gotcha. Good stuff. And the mass of the pendulum is, I think it was 10 kilos. Let's check. Oh, no, it wasn't. It was another kilos. It was 2. Then the mass rises. Well, I mean, it's technically this area, not rises. But that's supposed to be the change in Y. I don't know what remains better to calculate the bullet's initial speed. I think this was one of those energy deals. Potential, kinetic, potential and kinetic. Should I find the momentum? The change in momentum, the change in momentum. I could use a convoluted way to get to the answer. I think there's a better way with the energies. You know, there's the potential energy of at the point of the thingy of the pendulum, which is the mass bullet plus mass of the pendulum times gravity times the height. Wouldn't this be 2 plus 0.01 times 9.81 times 0.12, and that would be what? 2.01 times 9.81 times 0.12, 2.36, 2.36, that's kg ms squared meters. So it's basically kilogram meters squared per squared, which is joules. .36 joules of power, but that's not what we were looking for. Do we need the kinetic energy? I mean, the kinetic energy of, let's say, the bullet, because the kinetic energy of the pendulum is 0, we can ignore that. The bullet had. It's 0.01 times velocity squared. Velocity squared, we don't have it. So, we're just gonna plug that in there. So, times 2 or 0.01. I think the square root of that. I don't know how this is gonna go. Maybe I shouldn't have done all this. 6. It could be 7 technically, actually. 2 divided by 0.01. Square root of that. Yeah, that's horribly wrong. What if I do... Hey, what if I do mass G? As bullet or the square is equal to the... Wait, does it equal? Oh wait, there's... There are inelastic and elastic collisions here. Inelastic? Well... And 1, 2... Oh, wait, would you look at that? Mr. Logic. I mean, pretty much I'm computer way. We need to keep. Do we need? No. No, ignore that. But let me. MBV squared equals 2mgh m sub b sub p divided by what's the point? Square root. Maybe that'll give me what I want. Two times 2 1 divided by 0.0 1. Nope. Initial speed. What? Ah. Fine. Okay, what if we use the other one, the 1.5? squared. Now, 3 these are kinetic energies. We need them. I mean, we need this. We couldn't cancel. Let's do them as a B squared bar. As a P squared there. That's equal to B a P. And then we can create a 1/2. P is equal to half P times square root B squared all over P pendulum of the squared. Well, first of all, I think we get rid of those. Then we get B 3P squared. Actually, this is supposed to be whoopsie bullet pendulum. I should read and make those smaller, but they don't look like variables. Times, well, the square root is cancelled. Left and B squared. Wait, this is P, by the way. No, this is B. B. I mean, now P. To feed them. There's something went wrong. Let's manage to create the exact same equation somehow. I don't think that's a good sign. Oh. You know. What did I do wrong? Let me go back. Did I misuse something? I mean, if I do 2 times 2/1 here, reciprocal, I would cancel that. Oh, right. I got it. That's the way they shoes, I think. So so B P squared. How about we don't just kill them off? They already solved some stuff here. Technically have pendulum. You're not even allowed to do it in the first place. Who knows? I mean, actually, did that make it make sense? B squared. No. Something's definitely wrong in a different direction. So how about I go all the way back? all the way back. This is got my ass. Add. What did you say? Oh. Well, that's a final. I don't want those. Basically, okay. Let me use 1/2 mass of bullet. Because it's a bullet squared plus. Wait, is it times or plus? Well, these are initials. Pendulum. Pendulum. Initial equals. Well, this is 0. They move nowhere. 1/2 of bullet initial. No, final. And velocity squared final. Another 0. Plus 1/2 pendulum. Velocity squared pendulum of final. So we get 1/2 measure as pendulum velocity no bullet squared. 1/2 mass of pendulum velocity. What? Yeah, measure pendulum final. Well, I should use 2 not final. We squared. Yep, squared. I actually should use pendulum 2. Where's it? The F2s. 1. I know. Anyways. Well, no matter how I look at it, it would still become square root of there's pendulum. There's no pendulum final. Final. Sweet. Over mass bullet. Okay, this is getting weird. Maybe I should use the pre-made formula. Then okay, what do we get? Pendulum's energies first. Wow. Kinetic, mass, gravity. No. Velocity squared equals mass, gravity, height. 3 squared equals, I'm gonna say pendulum is, I would say 2 mass gravity height. Well, it's mass 1 times mass. Now, when it be divided by mass 1 is 2 squared. As a pendulum's mass, no, wait, velocity, final? Something final. Something velocity. Some velocity for it. So, if we want this be, what do we need? Do we need? Do we need its counterpart? I got a pendulum squared. This is, we just plug that in. We get the square of the 2 over mu. Oh, P1, 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 P2, P2. Okay, it didn't show. Squared. Then we can get rid of those. I don't think that's how this is going to work. B. This actually, this is 2. No, it's not 2. It would be pendulum gravity height. I think I just got somewhere wherever it's before. Pendulum 2. Would be 2 over b squared. I think I just managed to reach the exact same equation, wrong equation as before. I'm amazing. How convoluted can I get? 2 times 0.01 times 9.81 times 12 divided by 0.01. Yeah. And about potential energy. Who gets, when that gets original? What if? What if? What if? What if? Ja, ze zijn met de bullets on. So maybe I take B on. What if it's, yeah, I don't think that makes sense. It should be equal to, you know, what if I screw it and actually use the formula that was given to me? That's not the one I want. I'm gonna write that anyways. 1 well, 1 equals. It's gonna take one m1 minus m2 m1 over m plus 2 m2 m minus m2 times velocity 1 I think I plus m is it the same way? But just times velocity 2 sure? No. Is it? No. No. Right? No. No. Yes. V1 is no, it's no, not the plus. The top part is correct, but this is 2m2. V2i, 2i, V2i plus m2 times v1 I f 2m2 m1 plus m2 times 2v2i. Just zero it out. And we might flip those. One over v1 f over 1 times 1 over vf is equal to 1 over v1 f. Actually, times one over what's the easiest way to get rid of it? Actually, I could just isolate it differently. So v1 half times m1 plus m2 divided by m1 minus m2 equals v1 initial. We can ignore this because it's 0 basically, because the velocity to initial is 0. It's not moving. The pendulum isn't moving at first. What would be the values? The final. I don't think I have the final. Did I? Was I given the final? No. Not particularly. Ah. Ah. No, I don't think that's correct. That there's something wrong. The first one final. No, I mean the both after some momentum. You would have V2's final momentum. V2's final momentum. Because they're inelastic this time. I don't know if that helps. Fuck it. C. M1. Wait, what? Ooh. M1 plus M2. M1 plus M2 times velocity. I think 1 initial plus. Or maybe it's 2 initial actually. Is it? Which one is it? That's 1 plus M2 minus M1 or M2 plus M1 velocity U initial, right? M1, this is a flipped M1, M2. Maybe I get those top ones wrong as well. No, they were fine. That's fine. I'm gonna ignore that again. This is fuck. It's the V1 initial is 2 M1 over M1 plus M2 times M1 plus M2 over M1 minus M2. Oh yeah, there's a times VI. Now this thing is wrong. Technically all over 1. If I take the reciprocal, I would just cancel everything out. Yeah, I don't think this is correct at all. I don't think it's helpful. Most mysterious. Okay. Yes. Oh, that music. Amazing cleanup. Okay. So if you think about it, the plasma kinetic energy as well as squared is the blood. The pendulum is kinetic energy. Initially 0. The initial. From initial. Bullets secondary. Kinetic energy. Final V squared is equal to I mean, it could be the same as the pendulums. What the hell happened there? Huh? No, they become one of the pendulum final. Those kinetic energies are the same. We have the potential energy. The potential energy of the pendulum. What? Okay. We don't know even the final velocity of the pendulum. Because we know that those two are supposed to be equal, we can say 1/2. The final velocity is equal to mass grass. Mass grass height. I thought those cancel. Oops. Oh well. Oh well. I made this square by the way. Whoopsie. It'll end up becoming 2GH. 2GH. Okay, that's the pendulum's final velocity. So if I now do mass velocity initial is supposed to be 1/2 secondary mass times. No, I don't. I feel something is wrong. I'm gonna go with it. 1/2 mass. This one initial. Wait, 1/2 mass 2. Whatever. I don't. Technically, that will always cancel. So we'll be left with 2m2gh, and we come back full circle once again. Oh crap! What am I? Am I screwing? I know that's the wrong values. What if I? What do I? I'll look at the formula once more. If okay, what if I do final equals 2m31 m1 over m1 plus m2 Yeah. I think there was something wrong with those finals. No? Yeah? Whatever. Dessa times the one edition. The one edition is equal to V2 final times M1 plus M2 all over 2M1 hmm? Well, well, if we say that the second one's okay, what if we say that this is square root 2GH times M1 plus M2 over 2M1. Okay, what if I try that converted as plan? Can possibly go worse. Don't worry, it can get much worse. Somehow don't do it all by 0, 1. Nope. Where's 0, 0, 1? Is there a lock? Because of that. I'm losing it, man. 2 times gravity times time. You did do good go, correct? You're still wrong, but linear momentum fine, I'll go with momentum, mass velocity, mass velocity. A1 velocity 2. No, no, no. Measurable. Look at some. One 1.54. Droid. Okay. Screw me, screw my ass, kiss my ass. I'm a absolute genius. So it is 2 times square root of 2 gravity times gravity 9.81. The height along with 0.01 of the mass, which is all about 308. Well, it's actually about like 306 point something, but if we round the square root first, then we get something like 308 meters per second as the initial velocity for the bullet. Wow, it was that simple. God fucking damn it. Okay, so not that. What was the only important one? Not you. I'm not rewriting anything. This is really weird. Okay, I'll have to clean up. Okay, I'll have to make it bigger now. Otherwise this is going to take forever. Yeah, nope. Yeah, my dude. Okay. You know, I said I wasn't gonna redo it, but I have no choice. So, because of inelastic, we keep the same momentum. V1. Whoopsie, you're right. V1. V1 bullet. Bullet. Oh yeah. Mass 1 of the bullet. Whoopsie. Mass 1 of the bullet. Velocity 2 of the bullet. Oh, 1 of the bullet. Is the same as mass 2. Well, this is bullet pendulum. Velocity 2. Bullet pendulum combo. And so 1 equals mass 2 bullet pendulum combo. Velocity 2. I'm just gonna say velocity 2 of the pendulum. The pendulum all over. Velocity 1. Wait, what? No, mass 1. Mass 1 of the bullet. Mass 1 bullet. And we also know that the kinetic energy is the same as kinetic potential energy of the collections. So we have, and we're gonna use the pendulum, get the pendulum's final velocity. So we get 1/2 mass velocity 2. Is it velocity 2? Mass 2. Wait. What is different? Wait, what did I use? I used numbers. I already forgot my numbers. Numbers. No. Is that measure the bullet? The velocity of the bullet? No. Not that way. How did I previously come to square root mgh? Wait. We know that the measure 1 velocity 2, wait no, 1 is supposed to be equal to 1/2. Mass of the 2, velocity of the 2. And we know that's supposed to be equal to 1/2. No, not 1/2 anymore. That's supposed to be mass 2 GH. So using the trio. Wait, when did I add the 2.01 into the... Oh yeah, that's where. Right. I forgot that that's what mass 2 is all about. Well, maybe I should, leave it. Is it? Yeah, this is final. This is final. Mass 2 finals. Well, I mean, final as in when they're still moving. When the kinetic energy is still moving. On the move, you know? Velocity to final. Best to final. Wait, why did I just rewrite everything? I can just skip a few steps. I can get to the more interesting. I mean, this. Did they cancel? Wait, shit, that's not correct. Huh? Oh, man. I don't know. No. GH? No, 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 no. It's supposed to be. Ah, crap. What was it? Oopsie. Final squared? This is squared, by the way. Oh yes, it is. So is that one? No, no, no. Did I screw? I'm somewhere I'm screwing. Somewhere is wrong. Goodbye. JH? The pendulum? No way. Hmm? Is it supposed to be there? No, it couldn't be the first ones. Uh, to GH. I don't think actually these are equal. Are they? No, I don't think they are. Maybe I leave those guys out. If not. Are they? Well, if they're conserved, then they would be, right? Equal. Was it because I super solved? No. I don't think it is. We presume this is the truth. It will be 2GH speed. It will be 2G merge. 1 word. V1. No. No, 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 no. Actually, calculate something. The 2.01 times square root 101 times 2 times by the 1 0.12 divided by 0.01 divided by 0.01. What did I break? How did I break it? Oh, I broke. Ooh. He. Read it, boy. No. Are they finals though? Final 2? No? Ah, never. Never. No Bruce. Read it. I did magic and somehow I ended up in place. We try and logic through everything again. So we know we have one is gonna be the bullet. Already one bullet, which is gonna be the same as I have match 2 of the bullet. And velocity 2 of the bullet. And the one have out of 2 the bullet, and gonna be the same as the kinetic energy. After second. With this squared. Anyways, these are the pendulum elastic stuff, so velocity 2 squared is equal to velocity squared velocity 3. Those are equal, but also the mass 3 velocity 3 equal to mass 3 grammage h. I don't think this is right, actually. It might only be that. What is it? That's one mass velocity, one speed. Who cares? It's the same as the tools. Second velocity. We could replace with these two, but they still cancel. Which still leaves us with square root 2gh. They're still wrong. It's not what I'm looking for. You know what? It's not the right one. About what? About what? About what? About what? That's correct. Never mind. Never mind, I'm perfectly correct. We do 2, 3, whatever. Is the square root of 2gh. That is the bullet's second one. So this is the bullet's initial velocity is the same as, well, it's 2.01 or 2 plus 0.01 times, well, square root of 2gh. A little bit 0.01. 2 times 9.81. Maybe I'll make a bit tighter. 0.1 times square root of 2 times 9.81 times 0.12. Oh shit. Anyways, that all equals 308.45 meters per second. Maybe just round down. I guess you could even round up. But what is this square root over here? Hmm, 1.53. 3. Yeah, about we can round down or up. So basically, roughly we can say 308 meters per second. Ugh, that was actually quite the goddamn a journey. Okay, that took damn long. How many were? I mean, there's two left. I know I should stop a long time ago, but I couldn't help myself. I had to be correct. Okay. So this is 2 kilograms. Wow. Well, okay, it's on the table. There's a hole. I don't know why. There's again a bullet. Actually, we need to block the bullet. So it goes up and wait, no. I'll rather create this. No. Oh, don't do this to me. I weigh with a good bullet. That's a good enough bullet, right? Don't disagree with me. Okay, going up. So, mass of double wood. Just for exchange. 2 kilograms. Oh, bro. And this. Oh no, but I came back. Whatever. 0. No, wait. I mean, it's 7 grams. 7g times G, Hg, and Kg. So 1, 0, Hg, Dg, and G. 1 Kg equals 1, 2, 3. 1, 2, so 0.007 kg. No, it's no, it's 0.7 g, right? Kg. That's 0.07. Right? Crap. Where's my conversions? I'm bad at conversions. See? 7g in kg. It's 0.07. I was correct. Huh. How could I be? How could it be? How could I be so correct? I would just NG that one. The other one. That bullet. The other bullet. Da, 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 da. Anyways. So the oh bro. I mean I can just write that is equal to okay 25 cm times 1 meter over meter centimeter decimeter and then centimeter, so 100. Okay, so 0.12 0.25 0.25 meters. Always good to make conversions. Anyways, I don't think I have to really do this specifically in any exams, but good to do them now. So I get a feel for them always. How fast was the book going initially? Well, so it launches, so it's again the velocity 1. This is a bullet. I'm gonna use the velocity 2 of the bullet and velocity 2 of the bullet. And again, it's just mass 1. I'm gonna cancel that one out. Now to find velocity 2 of the bullet, we can just use the initial, the kinetic energy of the bullet. That's one, and velocity 2, which is no 1. Because it's supposed to conserve it perfectly, basically. Doesn't really happen, but happen in reality, but hey, we're not playing in reality. Oh, by the way, I keep forgetting this is squared. The same as magnitude of the 2. I did say 2, but I mean, I wanted to call them 3. Oh, that's right, 3. So these are the blocks of wood. Anyways, solving velocity 2. Wait, would the velocity 2? Oh shit. Ah crap, actually. I think I made a block of wood. Yeah, that works if I'm using the block of wood. Okay, so if I okay, I'm gonna make the one change, the logic change, that this water momentum is actually the block of wood. Yeah. No, otherwise I'm completely wrong about everything and nothing works. So let's just go with that. So because it is all true, we can now finally, with that confusion out of the way, we can finally have v squared, the block of wood, h. No, I mean those cancel. The wait. Yes. Anyways, we have v2, the block of wood thing is 2gh. So finally, I'm just doing this for practice, even though I knew how it would go. 2. No, it's actually, it's 2. Wait, what? Is it? Plus 0.007 times 2 times 9.81 times 0.25 all over 0.007. And all. Oh, hey buddy. Hello friend. It's been quite a while. I was about to waste a lot of writing space, huh? Until I decided, yeah, nah. Anyways, oh wait, it's in the square root, right? The squared. No, not squared, but square root. You take the square root of this. Yoink, a yoink, and yoink. Uh, 2.0. Oh shit. 7 times square root of 2 times 9.81 times 0.25 divided by 0.007, right? And that gives us about 634.99 meters per second, which we can just say roughly 635 meters per second. Okay, cool. And then there's one more, which is 10. Number 10. Okay. I'm learning. Can you believe it? Really thinking. Can you believe it? It's really simple. It's really similar. So this time, it's another block. It's also an no. What? Whoop. And we have the same hole. So like coming in. Okay, this time it's a mass is. I'm gonna mass 1 and mass 2. Because I didn't use that MV and M sub dub and M sub B anyways. Very should have. I'm gonna make this the. This might as well be the bullet at this point. It's 0.0 wait 003 kg, 3 grams times 1 kg over kilogram, hectogram, decagram, and then gram, and then 1, 2, 3, 0.00. And there we have our proof that it is indeed stuff. Wait, what? Oh, this time is not up. It's actually going horizontal. And the blocks. No, I don't actually need to do that. I need to do this. It slides. The bullet's still inside. Or whatever if the bullet doesn't stay inside? Slides. Or. And 1. Oh, yeah, I forgot. 2 is 3 kilograms. The velocity 1 equals 250 meters per second. Ooh. Sticks it in, yeah, sticks in. Then the block slides. So the delta. Delta X this time. At about 250 cm, which is actually 2.5 meters. 250 cm times 1 meter over meter, decimeter, centimeter is 1, 2. Perfect. Just for practice. the friction force between the block and table. Oh, well that. I'm gonna make another drawing. There's some. Oh fuck, there's a gravity force. We know there's a gravity force, we know that there's a normal force to counteract it, and then we know there's a frictional. The friction force. And there's force in the. Nah, I'm just gonna say X direction. So we wanna find the friction force. We don't really have the friction coefficient. Anyways. Wait, one of the forces. Some force within the linear momentums was. 3D rotation, no bro. Linear momentum. Wait, there's the word force. So the change in momentum. Oh, it's change in time. We don't have time. Friction force. What's normal? Wasn't friction force normal force times the friction coefficient? Let me check. Friction force formula. Yeah, it's normal force. Not helpful. Hmm. Oh. Hmm. The frictional force. Oh, I don't have the coefficient in. Wait, I don't know if that's allowed. Wood. Says it. Crap, that's not. Wood on wood. I don't think it's. Can I get. So if we say this is 0.2, do we? Is that correct or fair even? Mm. 0.2. It wasn't. Everybody's moving. The energy, do the energy's helping anyway. Huh. Hmm. Actually, we don't need this whole either. What is the help in fighting? Ability to. I'm gonna find it anyways. So M1, V1, the other one have of M2, V2, which is MGH. S2, Z2, we get Z2 equals for the 2GH. Actually, what's the collision? We know. Right, let me just. I mean, isn't that just actually that's correct. 0. What is it? Okay, for now it's 4905. 05. 49.05 meters per second. If it's set, then that'll just help with force. The force. We have time. Oh. Oh. I don't think it wants that. Clause? Oh boy. Resolution. Yeah, that might explain when it worked. I was looking at elastic collisions in the previous, one of the previous ones. No wonder my numbers never worked. Nope. Hmm. Force. Frictional. The normal force. I'm not wrong about it, am I? No. Oop. Hmm. Oh. Hmm. Yeah, what if I just try the change? One T, but hmm. Uh, 3.003 times 49.05 minus 0.003 times 450. I don't have its time value. I have no time values. Times 49.05. Maybe I can find it using another method. That means time value. Does that help? I mean, do kinematic Formula 11 do anything here? Purely in duty? Alex. OX. Final X. 18. Well, we wouldn't really know the mass. Force mass. Acceleration. Look. Typical for the 9.5. Yeah. Activate bomb. Um, here's another thought. One. It was the final square of initial square plus 2a. No crap, right. That was the delta x. The initial t plus half. What? God damn it, it keeps appearing. We have initial final to t 2 delta x. So the bar does show up. Oh, there we go. VO plus VF. I am not sure where this is all going. Divided by 0.016. So now I could have been 70. 0.03 times 49 minus 0 times 250 divided by the 20. What the hell am I doing even? Moment. How do you call it? Normal, yes, but it's not. Zoom, zoom, zoom. I mean, the momentum force momentum help me. Or whatever, but fraction of that force. Yes, that one's force. Fraction. What? Collapse. Hmm. Hmm. No, there's no angle. Normal for that. I don't have the I'm missing a piece, unfortunately. My understanding? Descriptions. Okay. Uh, Vision. Hmm. 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 Oh, gravity is only the high. Hmm. Right, it wouldn't work on this? Would it? No. Hmm. Hmm. Yeah, 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 yeah. Momentum, yes, but forces. As a force. Maybe I can find something. Force, yeah. Oh, wait, what? Mass gravity quotient theta? Oh, yeah, yeah, it can be that. But no, normal. Hmm. No? Requires something that I don't have. Hmm. Um, so close to. Okay, maybe I'll just ask ChatGPT for answers. Give me the answers. Man. Oh. Oh, well. do 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 do. Mm. Oh, what was it? What was the question? There's a question. Wait, should I? Okay. Yes, we know at the moment. This is important to me. What? Where's Boston? The work done by the friction force over distance? The change in energy? Kinetic energy? I mean, screw the value, but oh, the what is the work friction energy over distance, which is equal to the change in kinetic energy? Oh, right. So we have it equal to 1/2 mv squared over d 1/2 times it, the second one, right? 0.05 all over 2.5. I get the feeling that's not exactly correct. You know, sneaking suspicion for some reason. Five. Yeah, nah. Oh, right. Is there any more? You know? Oh. But yes, using the basics. Maybe we can do something soon? It? No? Maybe. A very good question. Why no? There is all, huh? When the kinetic exchanging energy be 2 minus v 2 squared, oh, no, 1 minus half V2. I presume it's the bullet version. If we would have. I'm gonna randomly make it here. How? Wait, what is it? Zero. Well, I'm 0.003 times 905 squared minus 1/2 times. Wait, this would be 3.00. This is 0.003 times 250 squared. And that's all. Let's just see what that is all about. Yeah, possibly be worse somehow. That's what we like to believe. But things you do turn out weird. 0.03 times 50 squared. Yeah, I don't think that's gonna go very well. Yeah, no, there's something fundamentally wrong about that. I think ChatGPT's value, something about its creation is wrong, or about what it has created is wrong. Yeah. Well, if we presume it's lead. How about that? That's actually kind of there. Almost there. And 50 cm, yeah. Like, interesting. It's almost there. It's just missing one crucial piece of information. Wouldn't be correct even then. Distance. Nah. I don't doubt its accuracy in the kinetics. The kinetics energy department in the formula, but something's missing. Something. What? Okay. 0.003 grams. B. No. Hmm. Hmm. 3. Udah. Hmm. Those those can some 003 50. Oh yeah, squid. Wait, trying to find the final one. Where's it? Okay, and there's also squid. Seven zero three divided by 3 divided by 0. No. 9. Half. Right. 3, 4, 7, 9. Nope. Nope. How did I define? Oh. I don't think that's great. Yeah, nope. Do I have to kind of concede on this? I got no clues. No clues anymore. There's something missing. Some vital piece of information. Piece of the puzzle. What? Hmm? 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 Velocity? Final velocity? Hmm? Hmm? Maybe final can it Hmm. Trees. Can't accept that so easily. This may be correct. Hmm. Hmm. Observed. Hmm. What happened when it that mean that 1 over m2 is equal to v2? But that means that. Would that be a possibility? No. Difference is 3. Difference is 3. 0. Half times 0.0 is 3 times squared. Hmm. Hmm. Oopsies. Hmm. Ah, shit. Whoopsie. Ah, okay, so it does work hard if you do it like that. So, this is nice. Why wasn't this everything? This everything? Not one was true? Hmm. So this would capture true? Hmm. Would. Oh, yes, right. I want to see my work again. 3 times 0.03 divided by 3.03. Oh, well. Oh, no. Nope, nope, nope. It's not it. Hmm. No, 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 no. I guess in this case, because of friction force, we can assume. No, can we assume that kinetic energies can screwed between the collisions because of the friction force? Perhaps. Perhaps. I'm gonna go with yes. Because I don't have better ideas. Hmm. Yeah, good. Hmm. Windows. Energy. Good. Yeah, I guess it's about correct. But the friction is screwing it. I was wrong about that. We can also get rid of that. So, but this is actually useful. So we could from that get the second velocity is the final velocity of the whole system is 0.003 times 250 all over 3.003, which was I can't remember. What? Okay, about 0.249, but we can just say 5 meters per second. I mean, I guess we should have the velocity things there, the vector variable indicators. Anyways, now the one part where it was correct is we're gonna make backwards, but where everything was correct was actually here to 5. Yeah. Wait. The kinetic changing kinetic energy. Shit. Wait, we actually look into that. That's something that's curious. Changing energy. No. Tell me a bunch of extra. Initial. Okay. I don't really. Look in it. Repons. Wait, initial? Huh. Square divided by minus times. No, it's not 250. Oopsie. No, it's shit. Final energy squared. Right. By 2.5 now. Yep. So G. Um. 0.003 and 0.25 or back to is Wait, what? Okay, that was wrong. That was wrong. Crap. Okay. Wait, I forgot. I've got to write a piece. Yeah. So about 3.37. Wait, there was a zero. There was an extra zero. 0.3. Whoops. Man, my 3.75. And we don't. No. The question is. Is why is it correct? Shoo, 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 shoo. This is not correct. Something about it is off. For some reason, it's the secondary kinetic energy that's only of interest. Yeah. Yeah. Hmm. Right. Okay. Okay, I think I get it. Right. Oh. Perhaps. Where is it? Varish. 3.75 minus. Well. I guess 1.3 plus. Yeah, but I mean, yeah, it would be the Shane. Therefore, I guess it's because I think the initial energy, then because the change in actually changing the changing of it, the change of it is the initial energy basis that we take the new energy which we remove from it, but the new energy is technically. How do we get the actual difference between them? I get that it's you remove the initial energy from the next the final energy, and then take that difference that happened. It basically becomes just the final energy equation. I'm still wrapping my head around that. Result from the final, yes, I knew about that. Keep free. Academy, will you help me to understand the rules? Oh, oh, ooh, ah, ooh. Well, Karen, that's working. You know, the final and initial. Versus. Where's it? Okay, that did not help. It only works if masses are the same. Wait, I have an idea. I have an idea. We mate. Got the idea of a lifetime. Right. Nice. Well, the initial. They're different. Yeah. I guess I can rationalize it with that. So we take that, then we subtract it from that. Because we're dealing with the new final energy. To get that final energy, we need to take the first energy and add that to the final energy of the second one. That's how we get that. But because of these cancel, at least in this case, we are just left with this boy. Okay, I think I roughly understand what I'm doing. So that's a great spot to end on. Okay, that's more than enough. Actually went way beyond overtime. How much overtime did I go? About 3, a bit over 3 hours. Whoopsie. Okay, anyways, bye bye.